The next project will be AgriFusion, a multi-factor explainable AI model for crop selection considering your Truthi batch, AML. Next batch will be Leaf Fusion, automated plant integration, Kavya batch. Next, Department of Electronics and Communication Engineering, Vehicle 64X high efficiency arithmetic engine, Dikshita batch. Next, Vidyut Rakshaka and IoT-based intelligent grid line protection system, Dandrajan batch. Next, Department of Computer Science and Engineering, BharatNet's AI-based heritage recognition system for Hampi, Karnataka using machine learning, Akif batch. Next is Department of Robotics and Artificial Intelligence, Design and Development of Mechanical Humanoid Robot, Yashwant batch. Next is an intelligent assistant robot for bidirectional sign language communication, Akansha Prajapati batch. Next is design and development of an AI-based robotic tutor for personalized learning and communication skills, Shahid and team. Next, AgriBoard, autonomous plant health and precision care system, Ganesh batch.
Pranam Sumarindal, before I start the presentation, as a convener from this conclave, I have a request. This is the students' case study, and we identified some of the projects from various departments, from the encouragement of the respective department heads and the respective guides. Students also cooperated, and they have given their project as a writer to be presented in the souvenir compiled by Dr. Santosh Krishna sir. And we just want to share that these kind of works are also going on in our institution, which we could map it to IKS, so that as in the morning session also, Professor Dr. Jerry ma'am told, like we will bring IKS as one domain from the next batch onwards in our project. So like that it is going to grow. My request to the kind audience, all our faculty members and the external participants, like kindly encourage this project. This is not their review. I again repeat, this is not their review to point mistakes and ask me questions. I repeat this request once again. Please don't make the students to feel embarrassing that they can answer, because already they have presented zero review, first review, all those things. But for the first time they are coming to a conclave, and in front of this much learned persons, they are going to present it in a different way. So I request you to encourage them and appreciate them. Okay, any discussions we can make it later. I hope you will all agree with me. They tried to use ML technology and image processing and scanning and all those things. So they read the palm leaf inscriptions which are in Sanskrit, and they translated it into English language. They tried for English language. The problems with this project was not that much successful. We had a success rate of only 65%. The reason is we were not able to get more data sets for this palm leaf inscriptions. We were not able to, because that was a starting point. I know some places where I could get the palm leaf inscriptions in Tamil Nadu, but I could not get it from Karnataka. Students tried. with very limited data set they did this one, and the translation also, only one student is Subramaniam Iyengar. He is familiar with Sanskrit, so he tried to help in decoding or translating it in the Sanskrit to English. So that was the starting point. This project was completed with a success rate of 60%, honestly we are feeling, and I repeat, it was also patented. This project was also patented. We will continue with the second batch. The all other 10 batches are ongoing one, 23, 27 batch. Thank you.
The next batch is Attribution Dhruti Sanjana under the guidance of the Amdes Agreement.
Good afternoon to everyone present here. Myself Dhruti and my teammate is Sanjana IKS. Our project is about Agri-Fusion, a multi-factor explainable AI model for crop recommendation considering yield, market price, and also this risk. And it is under the guidance of Mr. Tamaris P.D., Assistant Professor of Department AIML. Traditional farmings like crop rotation and also organic farming and also natural pest control all are recommended in this platform. And also we get a real-time weather forecasting and also it helps, it improves soil fertility, soil health and all. Where it helps the farmers to reduce the risk and also increase the productivity of the soil and also crops. It is a single smart platform with a blend of traditional farming wisdom with the modern AI technology to improve productivity and also reduce the risk for the farmers. Where we use a simple basic 5 steps methodologies, like we collect the data sets from different resources like soil, weather, crops and all, and we process the data sets to get the accurate analysis and also improve the quality of that, and also we train the AI models like for the crop recommendation, different and plant season and also market classification, and later we combine all the AI models into one and for the single platform, and here we provide farmers with a personalized recommendation for crops, disease treatment and weather updates and also market price prediction, and all is a single platform for the farmers where they can get every information in a single platform. Thank you.
So now let's see how our project is related to the Indian knowledge system. Our project strongly supports the principles of Indian knowledge system because it combines both traditional knowledge of farming and modern artificial intelligence. It promotes the sustainable agriculture by encouraging the eco-friendly nature, and it helps us to make it helps the farmers to make the better decisions using the both modern technologies and the traditional technologies also. And it also helps for the early detection and some weather conditions, helps to reduce the crop losses. And personalized crop helps in the improve the productivity and the crop yield. Also, it also encourages the efficient use of the soil, water, and other natural resources, and helps them to prevent the natural resources also. Finally, let me conclude our presentation. So, our agrifusion contains both traditional Indian farming and the power of the artificial intelligence also. It provides the crop recommendations, weather conditions, market prices, and disease detection in a single platform. So, it helps the farmers to increase the productivity and reduce the risk and market losses also. So, it is on sustainable agriculture, and it helps, it combines both traditional and modern technologies. It helps the farmers here very well. Thank you.
Next batch is Refusion Automated Plant Disease Detection using Deep Hybrid Framework and Expandable Attention. Kavya, Megha, Tejashwini, under the guidance of Divya, Department of AMI.
Good afternoon, myself Kavya. Our topic is Lead Fusion Automated Plant Disease Detection using hybrid framework and expandable attention under the guidance of Divya, Assistant Professor of Department AI. Introduction. In olden days, farmers feel very difficult to find the diseases in the field. So our project helps to find the disease earlier using CNN method, some AI models. Using that models, it will be easy to detect the plant leaf disease. So our project Leaf Fusion will help to identify which disease. Example, in tomato, we will find 3 types of diseases like early plant, monastic, by finding the disease name, we can identify easily.
Yeah, myself Tejaswini of Department of AI. Next is innovation. Innovation means what is new in our project. Here we are going to use 2 techniques, which is one is CNN and other is VAT method. Here what we will do means we will take healthy plants and unaffected leaves. In this, by combining of CNN and VAT method, CNN is conventional neural network. In this CNN, it will take only the small part of the leaf or area which is affected. This VAT method will take it will see the whole part where it is affected and remaining area it will leave. We will combine this both and we will produce the best decision, and it will tell what the plant which diseases it is affected to. Next, the methodology. Methodology means from the starting process to ending process. From first we will select the plant which is diseases and which is healthy. Here what we are going to do, we are taking one plant leaf. Here we will select what is the disease. First, image acquisition. In this, first we will from mobile or something the app we will take the photo of unhealthy plant. Next, image processing. We will see whether any unwanted noise. We will remove that all noise and we will make that part clear. Next, future extraction. As I told before, the 2 models we are using, that is CNN and the VAT. We use these 2 both and we will see that which part is affected. Future, we will combine both output models. If the plant is completely affected, we will go to VAT method. If a leaf in this particular part is affected, we will use CNN method. Next, attention mechanism. Why we will use attention mechanism? Because it is used to focus on the particular infected area. Only if a leaf, at the end of the leaf, if any diseases is there, it will focus on that particular area. Remaining part, it is okay. Then classification. After this process, the classification using deep learning. Here our main project team, we are using deep learning. Using deep learning, we will generate the output. Means we will tell which the plant, which diseases it have, and early blending or mosaic or black spot which it have, we will decide. We will detect.
Relevance to IKS. Our project is relevance to IKS. I can say yes, our project is relevance to IKS because it includes both traditional forming and modern methodological forming. Traditional forming it is used by the forming. They can't detect, farmers cannot detect diseases very fast. But in modern technology, at present modern technologies, using two techniques, they can detect the diseases very fast. So we can say our project is relevant to IKS. This is the images. Images first one is natural forming. Forming the fourth picture where we went to nursery to visit which plant. We talk to them about what the diseases. We found what diseases which plant make it fast diseases. We all discussed with the nursery people and we recently visited to nursery also. Conclusion. I can conclude our project is combination contributes for both traditional and the modern technologies. Combines technologies like AI, deep learning, machine learning. Using that we can detect the disease very fast and give accurate result.
Next batch is from Department of Electronics and Communication Engineering. 2064X High Efficiency Arithmetic Engine for the System. Dikshita, Kirti, Hanumanta, Kaki Gowda under the guidance of Professor Mahesh. Good afternoon, everyone. My Kirti and my team members are Bucket Goda, Dikshita and Hanumanta, guided by Mr. Mahesh, Department of PC. Our project is ALU 64X High Efficiency Arithmetic Engine for Risk System. The main aim of our project is to improve the process of performance by implementing ancient Indian arithmetic Vedic mathematics technique using the Urva Triyakbayam in a modern 64-bit disk processor. Urva Triyakbayam makes vertical and cross bytes. It is one of the sutra from Vedic mathematics. It is one of the ancient sutra among 16 sutras of Vedic mathematics. Unlike any other conventional multipliers, it is a multiplication technique which also calculates the multiplication, which also helps to calculate the multiplication technique where we calculate the partial product simultaneously in a cross-byte pattern, which helps to reduce the operational delay, also reduce the hardware utilization, also to increase the speed of the processor. Next is Vedic ALU 64X. Our proposed ALU helps to uses the 64-bit pipeline disk processor, which uses the Vedic Conclave as a core arithmetic unit. Here it uses the hierarchical multiplier technique, which includes 5 stages. One is instruction fetch, decode, execute, memory access as well as write back, where it fetches the data from the source and also helps to execute, helps to decode, also to access the memory in the proper way and to store the result. It also supports arithmetic logic and control units, also uses the math operations, which are widely used in many DSP or AI applications. How it is connected to Indian knowledge system. The project connects ancient Indian knowledge with the semiconductor technology. The Urva Triyakbayam Sutra naturally fits the parallel hardware design. Almost the studies have shown that it was 69% reduction in the LUT systems
electricity uses as well as 88% of lower power consumption. This also aligns with National Educational Policy of 2020, which encourages integration of Indian knowledge system into technical education. The main conclusion of the project is the ancient Indian mathematical knowledge can solve engineering challenges, which offers low delay, low power consumption, and higher throughput. The project proves that Indian knowledge systems are not just our heritage, but also a source of innovation for future technology. Thank you.
The next batch is Dhanraj Kirti Manoj and Shambhu under the guidance of Professor Suma PM. Project title is Vidyut Rakshaka and IoT based intelligent grid-line production system.
Dignitaries who are present in this occasion. Our project is a Vidyut Rakshaka, an IoT based intelligent grid-line protection system. Guided by Mr. Suma PM, aspect of department of PG. Our project is the protection of designs and also the arrangements who are working inside the data. So basically we are designing a robot which can alter humans effort without damaging their lives. So our project related to IKS is that it does not give fully automatic. It also deals with Asian knowledge as a principle for a project. So basically, IKS is the Indian knowledge system that developed by Indian ancient science. It is in the form of Upanishads, Sutras, and Samhitas. From that, we have taken different principles. For our project, we are basically having four principles. First one is Pancha Mahabhutas. Our teammate will explain about Pancha Mahabhutas.
Good afternoon, everyone present here.
Our project Vidyut Rakshaka draws an inspiration from Pancha Mahabhutas, which is five great elements: Prithvi, Jala, Agni, Vayu, and Akasha. Prithvi represents the physical power infrastructure. Jala represents the continuous flow of energy and environmental influences. Agni represents the electrical energy and fault detection, wherein our project detects the faults of electricity. And Agni represents the electrical energy and fault detection. Vayu represents the wireless we use different devices for wireless communications, and Akasha, which represents a cloud connectivity and an intelligent monitoring system. By integrating these principles with IoT and automation, our system aims to create a safer, smarter, and a more reliable power distribution network. Everything in this nature is composed of these 5 elements. So, our smart grid protection system reflects this philosophy by ensuring the efficient and safe protection for the electrical infrastructure. The Panchamahabhutas teach us that the use of sustainable development can only be achieved when these natural resources, when we use it responsibly. Any imbalance in these elements can lead to environmental degradation and resource depletion. So basically our project is mainly dependent on the electrical systems, wherein many electrical systems leads to the voltage fluctuations, short circuits and overheating. We use some fault damaging techniques like using fuses, relays and MCs. Using those, these devices can only disconnect the power after a fault when a fault occurs. But they cannot predict the future failures and they cannot provide the remote monitoring. Our project predicts the future failures and also provides remote monitoring. So we use sensors and many other devices, wireless communication devices and also the cloud integration. So our system continuously monitors the voltage, current and temperature. If the values remains same or safe, the system continues its monitoring. But if it has an abnormal, they are detected and they disconnect the electricity and also notify us through our mobile apps. Thank you.
Second principle is Arthashastra. Arthashastra is written by under the Chanakya's empire in the 4th century BCE. So according to Arthashastra, public infrastructure is the most important aspect in our day-to-day life. So our project gives public infrastructure with safety, which can be monitored 24 hours. It can predict the using of many techniques. So Arthashastra is also a very important role in our project. Next is the Rigveda. Rigveda tells that we should protect the nature and we should also respect our nature. So in order to deal with this, our project gives a very important role in providing electricity and preserving resources for future generation and without violating our nature's principles. And lastly, chapter Lord Krishna tells that humans should work for public welfare and nature's welfare without any demand for ourselves. So as engineers, we have to do the works with not only with technology and also with the social welfare and nature's aspect. So Loka Sangraha gives a very protective layer. As our project Vidyut Rakshaka also protect humans from robot interface without any damage or any accident for laymen without human interface. So lastly, my friend Manoj will conclude this topic.
The conclusion part is Vidyut Rakshaka integrates IoT, artificial intelligence, cloud computing, and automation with the guiding principle of Indian knowledge system. It provides intelligent monitoring, automatic protection, sustainability energy management, improved safety, and reliable power distribution. The ancient wisdom inspiring modern innovation for a smarter and sustainable power grid.
Now we have presentation from Department of Computer Science Engineering. The project titled Bharat Lens AI-based heritage recognition system for Hampi, Karnataka using machine learning. Presented by Akhil Varma Sharif and team under the guidance of Dr. Payal Purwal.
Good morning, everyone. Good afternoon, everyone. So basically, we are the students of computer science and engineering. Today, we are going to present IKS this project that's RSS and AI-based heritage recognition system for Hampi. Basically, why we have chosen Hampi is so that there is a vast variety of Asian architectures in our country. So it's a huge project. For as of our major project, we have chosen a project as Hampi to narrow down so that we get more insights on that. So India has a vast culture. So where we need to preserve our ancient knowledge. When we visit a temple and when we see architecture, where we understand how and why was this structure created. For this reason, we have come up with a project named Bharat Lenses, where we get our insight on what is this architecture based on and for why is it. So,
our project is basically a web application system where the user they can feel engaged of what they want to know.
The project is mainly for educational and research purpose. So how a humanoid robot is developed into IKS. As you know, in our Indian knowledge system, it represents the Indian scientific and engineering knowledge. So ancient texts like Vedas, other Shastras, and Samarana Sutradhara. So in Samarana Sutradhara, it's a mechanical devices and self-operating systems for yantras. So this concept inspired the modern robotics by promoting the efficient engineering and sustainability and practical thinking. So our project follows the same philosophy by developing a simple modular Vedas is going to relate with our project. So Vedas are the oldest text of India around the 1500 to 500 BC. They contain knowledge about philosophy, science, mathematics, medicine, astronomy. So they emphasize knowledge, observation, and scientific thinking. So as we know, the scientific thinking is a very basic and a common thing for any project or any technology or for the engineering basis. So we are taking the data for the related scientific thinking. And Arthashastra is written by Kautilya in the ancient world of governance, where it explains about economics and military strategies. So in the project, it discusses the method devices are used for security. So as you know, and engineering has a problem solving. So Arthashastra highlights the practical engineering and efficient system design, which are important principles for designing humanoid robots. And last one is Samarana Sutradhara. So it's an 11th century Sanskrit text written by King Bodha. So it mainly explains about architecture, mechanical engineering, and mechanical design and Indras nothing but the self-operating system. Also another word is automation. And to be it, so this is closest connection to our project as the mention of automation.
I will continue from IKS concept in my mind. First, I robot is a modular living in traditional Indian engineering. Such a strong, durable, and easy to repair. Similarly, modular design allows individually using the entire robot and making the system economic and sustainable. The second point is balance and stability. Ancient Indian architecture focused on proper weight distribution and structural balancing, so that buildings can remain stable for centuries. So we apply the same engineering principle in our humanoid robot by maintaining the center of mass and equally distributing the weight among the robots, which can possibly walk and stand without failing. Automation. Ancient India literature describes yantras, which are mechanical devices designed to perform specific actions. Our humanoid follows the same basic idea using modern electronics. Instead of mechanical gears, we use servo motors, controllers, and program to automate movement. The last one is sustainability. Indian knowledge system also emphasizes sustainability and efficient use of resources. Our robot follows this principle because it is low cost, less energy efficient, and designed for educational purpose, and also reduces the development cost. And at last, conclusion. To conclude, our project shows that ancient Indian engineering ideas which remain relevant in modern technology. We are not claiming that ancient India will humanoid robots, but we demonstrate that the concepts such as modular engineering, balanced design, and automation through yantras and sustainable engineering continues to inspire today's robotic system by combining both traditional knowledge and modern equipments. we are developing the humanoid robot. Thank you.
Next we have an intelligent assistive robot for bidirectional sign language communication presented by Pasam and Jayant under the guidance of Dr. Mohammed Salim.
Good afternoon to everyone present here. Myself is Jay Vijay and my friend is Pasam. Our project is an intelligent assistive robot for bidirectional sign language communication under the guidance of Dr. Mohammed Salim, Professor and HOD of Department of RNA. Most robot communicates through a speech or text limited accessibilities for people for a speech and hearing impairments. This project introduces a vision-based wearable free assistive robot that recognizes the language sign languages and the basis of CNN basic deep learning converts into a speech and text and enables seems two-way communication with the normal people and speech and hearing impairments. And it is related to the IKS, it will continue by customers.
Good afternoon, another friend here. I am going to relate my thought, which is the first thing is before the origin of language, which is normally spoken by us. Before that, we use sign gestures for the communication. Basically, that gives an idea for us to take up this project. Firstly, Indian sign language system is very vast, where it is described in all Bharatanatyam, dancing postures are there. Also, hand postures are inscribed in the temple areas. And our project is promotes excessively education and equal access for the parents who are facing speech, who face disability with speech and hearing impairments. And it also supports social welfare, empathy, and aligning Indian values like in our Indian values, Vasudhaiva Kutumbakam, which means the world is one family, which supports our project. And we use AI tools like CNN, PyTorch for making this possible. And our project enhances the communication of the people through by using robot. Robot is used for communication between the person who has a disability, and it is used for the other person who cannot understand the sign language. And it also demonstrates the traditional Indian values of service, compassion, and inclusivity integrated with advanced robotics and deep learning techniques. Coming to conclusion, my project enables seamless communication between sign language users and robots using AI, gesture recognition, speech and text, proximity, accessibility, inclusivity, and robot human-centric innovation.
So next presentation we have design and development of an AI-based robotic tutor for personalized learning and communication skills presented by Shahid and Samir under the guidance of Arun Kumar N, Assistant Professor, Department of ROEL.
Good afternoon everyone, my name is Mohammed Shahid and I am along with my teammate Samir. Our project is an AI-powered humanoid robot that makes learning interactive and personalized. So most of the traditional methods, teachers cannot focus on each student equally. So we have created a personalized robot which we can use in our homes. It has three AI agents, tutor agent, communication agent and tutor agent gives us personalized base plan which is according to the student's pace and smartness, how he studies. The second is communication agent, the second is tutor agent, and the third is speech agent. Speech agent is where we can access our communication skills and speeches or seminars. So it gives feedback according to our pronunciation. And the robot communicates with users through voice, answers questions, and provides personalized guidance based on their learning goals. Our goal is to combine artificial intelligence and robotics to make education more engaging, accessible, and effective for students.
Yeah, good afternoon everyone. I am Smith. And as our project is AI robot, which especially helps the group Shishya connection between students and teachers. Like Bruno was not the royal prince of Guru Kingdom. Like he didn't just give the normal knowledge to each and every student, he understood the capacity of student. Like he taught Arjuna the capacity of archery and the use of divine weapons, and likewise for Bhima he didn't teach archery, he taught like math combat and physical strength. Same goes for Duryodhana, he taught him the same thing which is math fighting and offense and with Bhima. He didn't teach each and every student the same way and same thing. He thought according to the student's perspective and capacity, he understood the student and then he gave the lessons to them so that they can do the best in their field. And at last, the conclusion for our project is we are trying to make a robot so that that the robot understands the user perfectly and teaches according to his capacity and capabilities in the best manner. We are basically trying to recreate the connection between Dronacharya and Eklavya. Thank you.
So last presentation for today, AgriBot, Autonomous Plant Health and Precision Care System, presented by Shahid Mohammed Saleh.
So, good afternoon, one of our present here. My name is Mohammed Saleh, I'm from Robotics Engineering Department. Under the guidance of Mr. So, my topic is AgriBot, Autonomous Plant Health and Precision Monitoring System. So, in the traditional farming methods in India, if you've seen, they use many different different farming methods. They had bowls, johars, and more traditional storage capacities. From them, I want to quote some. First one, traditional farming depends heavily on manual labor and conventional irrigation methods, resulting in inefficient resource utilization, delayed crop health monitoring, and reduced agricultural productivity. So, the first thing we are able to realize is that not all the farmers are able to take care of each and every crop one after another, again and again, right? So sometimes they might miss a crop, and when they use fertilizers or other things, they use it in a mass. Which even the healthy crop, because of these chemicals that nowadays are being used, those crops are also being damaged. Okay, and then it reduces the agricultural productivity of those specific plants. Farming robot that integrates computer vision, navigate optimize. Now, how is from before that you supposed to live in harmony with nature. You harm nature. By traditional education methods and resource management farming methods supports farmer welfare, align prosperity and self-reliance. For Indian culture, it's a backbone for Indian civilization. So my project and sustainable farming utilizes renewable solar energy, reflects the right use of natural resources. So our project promotes integrated and sustainable irrigation and water security. I want to end my speech with as well as agriculture. Everybody is raised to protect our plants, soil, and water today.
And in all very research and us to demonstrate Indian knowledge systems among our academic countries. Let us appreciate our developers. Now I request respected researchers to appreciate our teachers. I request all HODs, especially HODs from the various departments, and Department of AI. I call upon P1 in the absence here, and I request Dr. Dalal Sir to collect the letter of appreciation from our HOD, Gayatri. I just asked the letter of appreciation along with their name. Next we have Kavya and team, and I request the guide Divyaman to collect the letter of appreciation. Next, Deekshita and team. I request Mahesh, Department of EC. I kindly request the Professor Deepa team, HOD of EC, to come and distribute the songs.
because for them, not good. No
Next we have Dhanraj and P. Along with their guide, Suma PL. Now I request Telly from Department of Computer Science and Engineering. Team members Arif, Vicky, Mohammed Junaid, under the guidance of Fire. Now I request to call Dr. Mohammed Salim sir, HOD of Department Robotics and Artificial Intelligence. Student name is Yashwant and team, under the guidance of Mohammed Salim sir. Next team Akasha Prajapati, Secretary, under the guidance of Mohammed Salim sir. Next is Mohammed Shahid, Rajwanti, under the guidance of Professor Arun Kumarian. Next, I would like to call Manish and team under the guidance of Nandini ma'am.
ಪ್ರೊಜೆಕ್ಟರ್ ಆಫ್ ಮಾಡಬೇಕಲ್ಲ birthday parties. That video is there in YouTube. Photos it is in Kannaga sir. Yesterday we will give. Kannaga sir told his mood is off.
We would like to collect the feedback from the participants who are going to give the feedback. Kindly come and share your.
I will share, ma'am. Reading it.
Anyone from
Can you forward?
student side or
Okay,
faculty side, those who are willing to
I will
give
forward
the
this to
feedback,
Kannaga sir.
kindly come forward and give your views.
Kannaga sir should have some motivation.
அனைவருக்கும் வணக்கம். தமிழ் புரியுங்களா? ಸ್ವಲ್ಪ ಸ್ವಲ್ಪ ಗೊತ್ತಾ? ನನಗೆ ಕನ್ನಡ ಸ್ವಲ್ಪ ಗೊತ್ತು. இந்த IKS அப்படிங்கிறது ரொம்ப பயனுள்ளதா இருக்கு. There is a very useful program. நம்ம அரங்கசாமி சார் வந்து சென்னையில ஒரு இது வந்து ப்ரோக்ராம் சொல்லியிருந்தாரு. எப்படி ரங்கநாதர் கோயில் இருந்து இந்த ப்ரோக்ராம் ரொம்ப சூப்பரா நிறைய இன்ஃபர்மேட்டிவா இருந்துச்சு. ரொம்ப ஃப்ரெண்ட்லியா ஸ்டூடண்ட்ஸ் எல்லாரும்
And this is Shantamani. This is Nandini ma'am.
ಏನು ಕೊಡ್ತಾ ಇದ್ದಾರೆ ಏನು ಕೊಡ್ತಾ ಇದ್ದಾರೆ ಗೊತ್ತಿಲ್ಲ ಅಂತಂದ್ರೆ
Next, Dr. N.V. Dave on the comments floor.
Students presenters are requested to present same project what we have presented today tomorrow afternoon without fail. Sorry, on Monday. Monday afternoon without fail. Repeat your presentation on Monday before another audience.
So as we come to the closing of the IKS conclave, I feel proud to say that the last 2 hours has been truly encouraging and inspiring for all of us. This has given us a platform to revisit, understand and appreciate the vast knowledge that our Indian heritage has offered to the world of centuries. On behalf of our institution, I would like to express my sincere gratitude to our respected Chairman Sir, Dr. Prabhakar Reddy Sir, for his visionary leadership and constant support. I thank our beloved Principal, Dr. H.S. Nanda Sir, for the guidance, motivation and for creating an environment where such meaningful academic events can take place. To all the dignitaries, thank you for gracing this occasion with your presence and making it more prestigious. To our esteemed resource persons, thank you for sharing your expertise, research and valuable insights. Your sessions truly broadened our understanding of IKS. My sincere thanks to all the HODs, faculty members, participants and the staff for the coordination, efforts and dedication in making this event a successful one. Finally, a big thank you to all the students and participants for your enthusiastic participation, curiosity and discipline throughout the conclave. I am sure that the knowledge gained yesterday and today will inspire us to take a pride in our roots and contribute towards the preserving the IKS. Once again, thank you to each and everyone for being a part of this memorable event. Let us continue to learn, grow and uphold the spirit of our heritage. Thank you. Have a wonderful day. I request everyone to assemble near the main entrance for photo session.
ಇದು ಬೇಡ ಲೈವ್ ಬೇಡ ಲೈವ್ ಬೇಡ